So sometimes when we plug in, when you try and use substitution to find a limit, and we get a 0 over 0, an indeterminate form, right, the other tricks might not necessarily work. So I have this technique I like to call general shenanigans, or just being generally clever. And these are just kind of other techniques that kind of don't fit under the other headings. So, right, in the first one, we have the limit as x approaches 0 of 5x squared over 1 minus cosine of x. So if I plug in 0, right, I get 5 times 0 squared. So I'm going to get 0 in the top, 1 minus cosine of 0 is 1, right? So I'm going to get 0 over 0. So I know I have an indeterminate form. Put that off to the side. So, right, this isn't really rationalization or anything, but, right, we have trig involved. So that means we have all of the trig identities at our disposal if we can kind of create one of those inside of our problem. So what I'm going to do here is I'm going to multiply the bottom and the top by 1 plus cosine of x. So when I do that, if I multiply in the top and bottom, I'm going to leave my numerator factored out. And in the denominator, when I FOIL, I'm going to get 1 times 1 is 1, plus 1 times cosine is just cosine of x, negative cosine of x times 1 is negative cosine of x, and then I'm going to get negative cosine x squared. Right, so my middle terms are going to cancel out, and then I have 1 minus cosine squared of x. So now we want to recall that sine squared of x plus cosine squared of x is equal to 1, right? The Pythagorean trig identities. These are super important to know. You want to at least know this one off the top of your head. So if I manipulate this, this means that sine squared of x is equal to 1 minus cosine squared of x. So we can make a substitution. So instead of having the limit as x approaches 0, I'm going to actually put this down here to represent the denominator of 5x squared times 1 plus cosine of x all over 1 minus cosine squared of x. I'm going to replace that 1 minus cosine squared with sine squared, right? Those are equivalent. Okay. So now thinking back to our special trig limits here, right, we know that the limit as x approaches 0 of x over sine of x is equal to 1, right? Typically we write it as sine of x over x, right? It doesn't matter though because the reciprocal of 1 is still 1. So what we're going to do is we're going to try and manipulate what we currently have because it kind of looks a little bit like x over sine of x. So we're going to use some limit properties to pull this thing apart. Sorry, my Apple Pencil is having some problems. Hoping it doesn't die on me. So instead of having 5x squared on the top, I'm going to pull the 5 out front, and I'm going to write this as, well, x squared is just x times x, and sine squared is just sine times sine. So I'm going to write this as x over sine of x times x over sine of x times 1 plus cosine of x. Right? Because if I were to multiply everything back together, I would get the fraction that was in my previous line. So I'm just deconstructing what we currently have. But now, technically this is all in brackets because we're taking the limit of the whole thing. So now I can take the limit as x approaches 0 for all of these parts. So the limit of 5 is 5, right? And then we know that the limit as x approaches 0 of x over sine of x, right, that's equal to 1. So I'm going to get times 1 here, times another 1, and then I'm going to get 1 plus cosine of 0 is 1. So overall I get 5 times 2, which is going to give me 10. Right, so that's kind of what I mean by like a general cleverness strategy, or like kind of like, I call them shenanigans, right? You're just kind of pulling a trick off, right? So if you can kind of manipulate things to make them into something else that are equivalencies, then you can kind of break it down and use known special trig limits or other techniques to help you get to the end result.